Okay. You might get different numbers when you do this one on the homework, but I'm going to show you how to work this one out. A researcher claims that the number of homicide crimes by season is uniformly distributed. To test this claim, you randomly select 1,203 homicides from a recent year and record the season when each happened. The table shows the results at alpha equal 10%. Test the researcher's claim. Okay, let me tell you what uniform means. He didn't give us, percents of spring, percent of summer, percent of fall, percent for winter, but he says uniform. Uniform, guys, means that they all are the same percentage. So what you do in this case, in order to find the expected value, these are called the observed values right here. In order to find the test statistic and the p-value, you need the expected values. You take the total and you divide it by the number of categories. So 1, 2, 3, 4, you just take 1203 and divide it by 4, and then you get the expected value. So usually when he doesn't give you different percentages, it's easy. You just get the total and divide it by the number of categories to get the expected value. So all of the expected values will be exactly the same. What I taught you here in section 10.1, as far as stating the null and the alternative hypotheses, you say that the distribution is as claimed and the distribution is not as claimed. Where here you say the distribution is uniform and then the distribution is not uniform. So here, uniformly distributed, and here is not uniformly distributed. So when it comes to uniform, guys, this is how you state the null and the alternative hypothesis. Okay, let's go to the calculator and show you again, just to review this section, how to set this up. So I'm gonna stop sharing here and take you to the calculator and input those values. Let me just bring the calculator up. Recording. So stat, edit. I'm gonna clear L1 and I'm gonna clear. Look, how do you clear the list? L2 and then hit enter. Clear and clear and then enter. There you go. So for the observed values, I got 309. Enter. I got 318. Enter. 291. Enter. When you do this homework, if you get the same value, that means I've done the homework for you here. Okay, for L2, what was the total? 1203 divided by 4. I think the total was 1203. Yeah, 1203 divided by 4. And 1203 divided by 4. You can put 300.75, same value, and 300.75. Let's say, guys, you have 5 categories or 6 categories. You take the total and you divide it by 5. If you had 6 categories and the total, let's say, is 1800, you divide 1800 by 6. Okay, now we're ready to run the test. But before we run the test, can you tell me what the degrees of freedom for the goodness of fit here? If you have 1, 2, 3, 4, the degrees of freedom are number of categories minus 1. So 1, 2, 3, 4 minus 1 will be 3. So go to stat, tests, scroll up, goodness of fit test. Okay, L1, that's my observed values. L2, my expected values. And this is a 3. All right, and then let's do a draw if you like. Okay, here's chi-square. Here's the test statistic, 2.356. And the p-value is 0.5018. Okay, what's the question here? A researcher claimed that the number of homicide crimes per season is uniformly distributed. So the claim is in HO. So you got the test statistic, you got the p-value, which is 0.5018. When you click next, guys, it's going to prompt you to enter the value of the test statistic, and then next you enter the value of p. And then which is more than alpha, you fail to reject the null hypothesis. And if you fail to reject the null hypothesis, you say there is not enough evidence to reject the claim that the distribution is uniform. So we don't have enough evidence. We don't have sufficient evidence to reject the claim. So this is how you work with uniformly distributed claims. Any questions here? Yes. Questions? All right. Here's another question, guys, from section 10.1. He gives you the observed values. For a recent year, the following are the number of homicides that occur each month in the city. The previous one was by season, now by month. And you have the data from 12 months. Based on the result, does it appear that homicide in the city occurs more often in certain months? That is the distribution not uniformly distributed? So here, guys, you put the distribution is uniform in HO. In HA, the distribution is not uniform. But how do we enter those values as observed and expected? You enter the 12 values in L1. These are the observed values. And can someone remind me, how do you do the expected values for this one? Yes?
Would you add them and then divide by 12?
Yes, exactly. Add them up. He didn't give me the total. I'm trying to find anywhere for the total. He didn't. So we just add him. It's okay. We'll add him and then divide by 12. And that's what goes in L2. So let's say you get, guys, 400. It will be 400 divided by 12 in first value, 400 divided by 12 second, third, fourth, the same value all the way to 12 values. And then you go and run the test. Remember, the degrees of freedom here, since I have 12 months, is 11. So make sure that your degrees of freedom is 11. All right. Here's another one. I'm just going to review 10.1, guys, before I start something else with you. The pie chart shows the distribution of the opinion of parents on whether a college education is worth the expenses. An economist claims that the distribution of the opinion of teenagers is different from the distribution of parents. To test this claim, so the distribution of the opinion whether a college education is worth the expense is the same as teenager and parents, and here is different for teenager and parents. So this is the null and the alternative hypothesis. Okay, these are the observed values, guys. 86, 64, 34, 16, 5. The given values are always the observed values. The expected values. Okay, the expected values, you need the total, which we already know. It's 205. It's given in the problem. And what do you do for the expected values, guys? You can see the pie chart. How do you find the expected values? You're not going to divide by 5 here because you have different percentages. So what do you do to find, the expected values for strongly agree? Yes? No feedback? Can someone tell me what would be the expected values here? Go ahead. Can you guys hear me?
Yeah.
Okay, go ahead. What would be the expected value for strongly agree?
55%.
Of what?
Would
Of
be
the
up.
total, which is 205.
Oh, okay.
And then 30% of 205. So let me just do this here, show you the expected values. Okay. So for L1, guys, you just enter the values given in the table: 86, 64, 34, 16, and then 5. Look, for the expected values, okay, the first one is 55%. So 55% will be 0.55 times 205. There's the first value. What was the second one? 30%, and then I have 5%, 7%, and 3%. So let's go back. 30% will be 0.3 times 205. Then we have 5%, that will be 0.05 times 205. And 7%, it will be 0.07 times 205. And finally, for the last one, it says 3%. So it will be 0.03 times 205. Enter. And then, guys, you just go to stat, tests, goodness of fit test, and you run the test. L1, L2. How many categories? I have 5. So 5 minus 1 will be 4. Make sure to change the degrees of freedom and hit calculate or draw if you like. Let's hit calculate here. Here you go. This is the P. This is the test statistic. And look at the p-value, guys. Again, don't make the mistake of just copying 1.1656. You see the e minus 12 here? The e minus 12 means you have to move the decimal point 12 digits to the left. That means it's 0. So you just put 0.000 as your p values. And then it's less than alpha. You reject the null hypothesis. And if you reject the null hypothesis and the claim is in HA, you support the claim. So there is enough evidence to conclude that distribution is not of parents and teenagers are different. So usually the null hypothesis is the same. The alternative hypothesis, the distribution has changed or it's not the same. Any questions? Okay. Just gonna go to one question now from section 4, and then we'll go to the new section, section point 2. Okay, this is a question from section 10.4. The table available below shows the weights in pounds for a sample of vacuum cleaners. The weights are classified according to the vacuum cleaner type. At alpha equal 1%, can you conclude that at least one mean vacuum cleaner is different from the others? This is what we call ANOVA test, the one-way analysis of variance. When you guys see 3 samples, you know this is the last section in your book, 10.4. So you should know that this is the ANOVA test. He wants us to test if one mean is different from the other. So this is how you state the null and the alternative hypothesis. You have the vacuum type, bagged upright, they call it BU, bagged upright, bagless upright, and top canister. Okay, the null hypothesis will be mu1 equals mu2 equals mu3, but he didn't use 1, 2, 3. He used the abbreviation, of the name. So which one would it be? It would be this one, B, because this is mu1 equals mu2 equals mu3. As I told you, the HA never changes. At least one mean is different from the others, and that will be B. And then, see, check the answer. And now the test statistic. Would someone remind me how to find the test statistic for this one? Okay, I guess I'll say it. So you put the data from the first sample in L1, the data from the second sample in L2, and the data from the third sample in L3, and you run ANOVA. Let's do that. Just gonna show you how to work this one out. So stat, edit, enter, clear. Okay, what do we have? 21, 18, 20. 18, 20, and what else? 22, 24, 23. 22, 24. So all you have to go, guys, back and just redo what I'm doing right now. Clear, enter. Okay, we got 21. They seem to be the same. 22, and let me see what the rest is. 22, 20, 20, 18. Okay, the next one. You see, they don't have to have the same sample size. They can be different. The top canister is what? We have 23, 22, 25. And I got 21, 24. Oh, we got 20, 20, 18. So I missed something there. 23, 22, 25, 21, 24, 22. Oh, I missed the other 20 here. So I'll go back and put it there. All right. So here's what you do now. You go to stat, tests, scroll up. It's ANOVA. Enter the lists, second, and then number 1, comma, second, and then number 2, comma, and second and number 3, close and enter. And here's the test statistic, guys. It's 2.755. If it says round to 2 decimal places, it will be 2.76. And the p-value will be 0.0956. And what is he asking us to test at what? Alpha equals 0.01. So this is bigger than alpha. You fail to reject the null hypothesis, and you say there is not enough evidence to support the claim that one mean is different from the others. So this is the review for sections 10.1 and 10.4. To make the video short, guys, I'm going to split up the recording into several. So I'm going to stop the recording and do a new one.